The most difficult part of launching a rocket is the liftoff, overcoming Earth's gravity to propel a massive spacecraft into the sky. The most crucial component that makes this possible is the rocket engine. These engines are incredibly complex and expensive to manufacture, often accounting for over 70% of the entire rocket's cost. Even a minor issue in an engine can spell disaster for the entire mission. This is why rocket engines are at the forefront of innovation and engineering. In the case of the recent Starship flight, as we all know, it achieved some incredible feats, but also ended in tragedy. Reports suggest that there were issues with the engines during the flight, and these may have even contributed to the mid-air explosion. Today we'll dive deep into the details of what went right and what went wrong during this mission. Before we delve any deeper, please take a moment to subscribe to our channel for future updates and to stay informed about SpaceX's groundbreaking achievements. The Starship Flight 7 began with great promise, but ended in an unexpected and dramatic twist. The mission kicked off at precisely 8 a.m. local time when Booster 14 fired all 33 Raptor engines, lifting Starship 33 from the launch pad at SpaceX's Starbase in Boca Chica, Texas. This marked the first critical milestone, achieving liftoff with flawless engine performance. Over the next 3 minutes, B-14 propelled S-33 to the altitude necessary for the critical hot staging phase, where the Starship upper stage separates from the booster mid-flight and ignites its own engines. At T+3 minutes 45 seconds, hot staging was initiated, and Starship successfully detached from the booster. However, moments later, at approximately T+4, an anomaly occurred. A fuel leak above Starship's methane tank was detected, leading to ignition and a visible fire near the flap hinge area. The fire rapidly escalated, compromising the structural integrity of the spacecraft. By T+4 minutes 10 seconds, the onboard flight termination system was activated as a safety precaution, resulting in a dramatic mid-air explosion. Debris scattered across the Caribbean skies, marking a somber conclusion to a mission filled with both triumphs and challenges. Despite the catastrophic end, the mission offered valuable insights. During its brief ascent, Starship achieved several technical milestones. The booster's Raptor engines set a new record for thrust and operated without issue during the initial ascent. However, subsequent reports suggest that engine-related issues might have played a role in the upper stage's explosion. Specifically, it is possible that residual stresses on the engine components during the hot staging phase could have contributed to the fuel leak or ignited vapors near the methane tank. One potential issue lies in the immense pressure generated by the Raptor engines, which, while delivering unmatched thrust, also push the boundaries of material limits. The full-flow staged combustion cycle used by the Raptors introduces extreme thermal and mechanical stresses, particularly during transitions such as hot staging. If even a minor flaw, such as an undetected crack or irregular weld, occurs in the engine's intricate plumbing, it can cause catastrophic results under these conditions. Additionally, the redesigned fuel feed system tailored for the Raptor vacuum engines may have introduced unforeseen variables. Before the flight, SpaceX has already made several updates to improve the Raptor engines. These changes included increasing the propellant capacity by 25%, which helps the rocket carry more fuel and operate longer. Another upgrade was adding vacuum jacketing to the feed lines to keep the fuel cold and stable. This is particularly important for the vacuum version of the Raptor engine, which is designed to work in space where there is no air pressure. SpaceX also redesigned the fuel feed line system to make sure methane and oxygen flow smoothly to the engines, reducing the chance of blockages or uneven supply. They added new avionics for better control of the engine valves and improved data processing, allowing engineers to monitor the engines in real time and make adjustments if needed. The engines used on Flight 7 were the Raptor 2 models, which are an improved version of the original Raptor engines. Raptor 2 has a simpler design, fewer external parts, and produces up to 230 tons of thrust at sea level. However, even with these improvements, the engines faced extreme conditions during the flight, especially during the hot staging phase when the upper stage separates from the booster. Some reports suggest that these conditions may have contributed to the fuel leak and explosion. SpaceX is already working on the next version, the Raptor 3 engine. Raptor 3 is expected to produce over 280 tons of thrust, and Musk has mentioned that it could reach up to 330 tons in future updates. This engine is being designed to be even simpler and more reliable, with an integrated cooling system instead of external heat shields. Raptor 3 is still in testing and might be used in flights as early as Flight 9 or 10, depending on how development progresses. In the future, SpaceX plans to develop a Raptor 4 engine, which will focus on making the engines last longer and work more efficiently. There is not much detailed information about Raptor 4 yet, but it will likely play a big role in SpaceX's goal of making Starship fully reusable and able to handle many flights to places like Mars. SpaceX is actively preparing for its next Starship test flight, aiming for a launch as early as the first weeks of February 2025. This follows the recent Flight 7 on January 16, 2025, which, despite a successful liftoff and booster recovery, ended with the Starship upper stage exploding over the Caribbean due to a fuel leak. In response to the Flight 7 incident, SpaceX CEO Musk indicated that the company plans to address the issues identified, including implementing fire suppression systems and increasing vent areas to prevent similar occurrences. Musk stated, "Nothing so far suggests pushing next launch past next month." SpaceX aims to conduct up to 20 Starship test flights in 2025, focusing on refining designs, achieving orbital recovery of Starship, and demonstrating orbital refueling capabilities. Meanwhile, Blue Origin has shocked us all with the successful launch of its long-awaited New Glenn rocket. Let's be honest. When they announced the launch date, most of us thought it would just be another delay in a series of postponements. But against all odds, they surprised us with a liftoff that marked a historic moment for the company after years of anticipation. The New Glenn rocket, named after astronaut John Glenn, launched from Cape Canaveral Space Force Station on January 16, 2025. Standing at an impressive 98 meters tall, New Glenn is a heavy-lift launch vehicle designed to compete with SpaceX's Falcon Heavy and Starship in delivering large payloads to various orbits. The rocket's first stage is powered by 7 BE-4 engines, using liquid oxygen and methane propellants, while the second stage is equipped with 2 BE-3U engines optimized for vacuum performance. The mission successfully deployed its payload, the Blue Ring Pathfinder prototype satellite, into medium Earth orbit. This achievement demonstrated that the rocket is capable of performing its primary mission, silencing skeptics who doubted Blue Origin's ability to deliver after years of delays. However, the celebration was tempered by a notable failure. The reusable first-stage booster, designed to return and land on an ocean platform, didn't make it back. After completing its burn, the booster attempted its descent, but telemetry was lost during the critical phase and the landing was unsuccessful. Blue Origin has yet to recover the booster and is conducting an investigation to determine what went wrong. That's all for today's video. Thanks for watching, and we'll see you next time.